Hi guys and welcome to, yes, my live stream number 3 on the Further Maths, now called General Maths, let's not get it right, stream on financial maths. Hopefully you guys can hear me. If anyone out there is watching and will actually just send me a message and say, yo, I can hear you, that would be great. Evening, the Felix Raving. Really good to see you. Well, not to see you because that's a bit weird really because I can't see you. I'm just talking to myself in a recording studio. But fingers crossed you can hear me. And I'm going to get started in a while. Thank you very much, Path. Greatly appreciated. Now, if you haven't watched the other live streams, don't worry about it. All right, I'm working through the Cambridge book with all the financial stuff, which has all been redone for general maths. But this lesson can sort of stand on its own. I'm going to finish chapter 7, if that makes any sense to you. Then I'm going to slam straight into chapter 8. That's where stuff becomes incredibly funky. Now, as I tend to do, you know, I do a bit of a recap, and in the previous sort of live streams and lessons and whatever you've been dealing with, basically you can, we've been dealing with recurrence relationships and rules. Really important to know the difference between them and obviously how to convert between one and the other. That's fine, you know, that's fine. But a lot of the real world applications are actually now what's going to happen more and more in this particular concept. And all of the interest rates, all the stuff we've dealt with so far with simple interest and whatever else, is basically always had an annual interest rate. We've always had something along the lines of, say, 3% PA per annum. Now, what does that mean? It basically means that at the end of the year, I'm going to get interest just once. But that's not real life. No one pays you interest just once. How are banks going to make an extortionate amount of money? Well, basically, we use interest rate conversions. And this is pretty massive because I can guarantee you of all the questions that's going to come up, basically, yep, these are the things that are going to trick people. So let's look at the beautiful little sign here. We've got a wonderful savings account that's going to pay 4% per annum. Really? Actually, no. Believe it or not, you actually get more than 4%. Huh? Well, why don't they advertise that? Well, sort of. They do down in this small print. Sorry, someone just said, I missed the lesson. Is it possible to watch the recording? Absolutely. They are all on Maffs Guru. Sorry, my YouTube channel. If you click on live stream or live, the last live streams that are there, watch them over or head over to maffsguru.com. He says right in highlighter, knowing this is going to disappear in a moment. And basically, the whole course is already pre-recorded for you. Easy, really. Okay, and they're all in bite-sized chunks, all mapped to Cambridge. And I want to thank Cambridge really because they've allowed me to use their examples. Anyway, enough of that rubbish. I feel like I'm doing some sort of a commercial. Now, the point of it is interest can be paid in all sorts of different ways. And what we're going to look at very quickly is the idea of paying it quarterly. That's every 3 months, or monthly, or daily. Now, actually, as it turns out, if you take out a loan, or you take out, you pay money into a bank, you're actually given interest daily. Why? Why would they pay interest daily when they're advertising at 4%? Well, I don't know about you, but I actually want interest on my interest. So if I've got money in my account, I actually want to start getting interest on everything that's in there. I don't want this simple interest rubbish. And if you've got no idea what simple interest is all about, well, that's fine. I've got a video on that. It's good. All right. But simple interest, they just pay you one fixed amount of interest. Well, that's rubbish. No one's going to do that in real life. Hopefully not. Now, how do we convert interest rates? Well, you always start with the per annum amount. So for example, if I've got an interest rate of 12% per annum, so that's 12% per annum, and I want to work out what that would be per month, well, what I've got to know is how many months there are in a year. And you're looking at me as you have to say, who on earth doesn't know how many months there are in a year? Sadly, quite a lot of people, all right? No, believe it or not, yeah. You ain't going to say, I love you too. I don't know what that means. And probably will get me somewhat arrested. But we're going to divide that by 12. That is going to give me a 1%. Now, what that means is, I now have an interest rate of 1% per month. I'm looking at all of my calculations now being monthly. But what about if they actually paid interest per fortnight? Well, in that situation, I would do the nominal interest rate, and again, I'll come back to that in a moment. That's a yearly interest rate, my per annum interest rate, and I would divide that by the number of fortnights. That goes 26, so 12 divided by 26. If I had quarters, 12%, I would divide it by 4. Which would mean I would get 3% every quarter. Now that's going to become a pretty important skill as we work through the rest of all of this. And you're going to say, why? Well, let's do some examples. I like to do some examples just because this is a CAS-enabled course. Obviously, we can use our CAS. They're not going to give you nice numbers like 12. Here we go, 4.68% per annum. All right, convert this interest rate to each of the following rates. A monthly rate, well, in that situation, what would I do? 4.68%, and I've got 12 months in a year. So if I fire up my TI Inspire, now guys, if you've actually got a class pad, don't worry about it. The functionality is pretty much the same. If they are massively different, I'll do what I can to help, but 4.68, divide that by 12, put it in there, is going to give me, hold on a moment, 39 on 100. Well, not going to do that because my calculator is in the wrong mode. And whenever I tend to deal with general maths, I go to settings and status, document settings, and I'm going to change this to actually approximate. Click on OK, up, copy it down, hit enter again, and basically that gives me 0.39%. And you're going to say, well, why are we doing this? Basically, we are doing this because it's going to be important later on for our recurrence relationships and all our other things. What about fortnightly? All right, so what about fortnightly? Well, again, in that situation, 4.68 divided by 26. Again, slam it into my calculator, 4.68 divided by 26. Hit enter, 0.18. And again, that is percent. So many people, when they do this, actually make huge numbers of mistakes. The reason they make mistakes is because they forget the percentage sign and they start using this 0.39 in calculations. So those of you who want to smash general maths later on, these are the things I'm going to point out. All right, I've got years and years of experience of watching people make silly mistakes and lose stuff. And in previous videos, I told you examples of students who've lost 8 marks across their whole VCE exam and gone from a 50 to a 32. Now that was a particularly tough year, but the more marks you lose through silly mistakes, the worse it actually gets. All right, and quarterly, what would I do? I would do 4.68 divided by 4, and again, bang there my calculator, 4.68 divided by 4. He says, not typing on the screen, 4.68 divided by 4, hit enter, 1.17. So 1.17%. And again, these are all important. It's coming up. You're beating me, Maths Guru. That's okay. It's not a competition. Okay, now you've made it a competition. All right, let's turn the calculator off for a moment. Brian borrows $5,000 from a bank. He will pay interest at a rate of 4.5% per annum. I'll answer sort of questions as we go on. Let Vn be the value of the loan after n compounding periods. Write down a recurrence relation. Now, I've been teaching this today myself, and I keep going on and on and on about recurrence relations. The number of people who don't know how to do recurrence relations, or at least write them properly. So in this situation, write down a recurrence relation to model the value of Brian's loan if it is compounded. Well, a recurrence relation starts with V0 equals, so that's going to be my 5,000. I'm going to do a comma. All right, so put that comma, really important. As I've said before, in a VCAR exam, you actually get 1 mark for writing the correct value of V0. You have to have that comma. The next thing goes, V of n plus 1 equals. Now we want this capital R, all right, because this is a compounding, because it is compounding periods, we need to work out our value of R. And we know that R is equal to, what is it? In this situation, 4.5 divided by 100. And I'm going to add 1. Now, why is it divided by 100? Because I've got to turn that 4.5% into an actual decimal, and I add on 1 because interest gets added on. So again, I always use my calculator to do this. I don't trust my head to do 4.5 divided by 100. And a lot of people go, but why? All I've got to do is make one silly mistake and I'm in all sorts of trouble. So I can now delete that value of R. And I'm going to put that as 1.045 times Vm. Ka-ching. Job done. There we go. That is my recurrence relation for yearly. But what about quarterly? Well, believe it or not, it's pretty much the same thing. Why? Well, because we start with V0 is equal to 5,000. I do a comma. That V0, that's my start amount. But now I've got to go V of n plus 1 equals my value of R. Well, haven't I just worked out my value of R? Well, yes, for yearly, but now I'm quarterly. Now I've got to take this 4.5% and turn it into a different value. Oh, well, I'm going to do 4.5 divided by 4. Now, if you're following the Cambridge textbook, they've actually changed the way they teach it this year, and I don't really particularly like the way they do that, all right? So I tend to stick with the same thing, 4.5 divided by 4. Stefanos Tuavi, I'm going to ban you in a minute because you're actually making this harder than teaching. If I actually teach you and I find out who you are, this is going to make life very, very interesting. All right, so 1.125. So let's turn that off. So it's 1.125. Now again, that's percent. If I now want to work out my value of R, I have to do 1.125 divided by 100. I have to turn that percentage into a decimal. I'm going to add 1 because I'm increasing. My interest is being added on. So again, fire up my calculator. Let's divide that by 100. And I'm going to add my value of 1. And in which case, I would therefore have that value of R is going to be 1.01125 times V of N. No, don't apologize, Stefanos Tuavi. Honestly, I love the fact that it's humor. Last few ones I've done of this, I pretty much talked to myself and it got really awkward after a while. In fact, I was going to give them up. I wasn't going to do any more of these because I was like, I'm literally talking to myself. What about monthly? Same idea, believe it or not, because what I've got to do now is I've got to convert my 4.5 into a monthly interest rate. So what have I got? 4.5. I would divide that by 12 in this situation. So 4.5 divided by 12 gives me 0.375%. My value of capital R then would be 0.375 divided by 100 plus 1. So let's divide that by 100, add my 1, gives me, so I would end up with V0 is equal to 5,000, comma, V of N plus 1 is equal to 1.00375 times V of N. Now, some of you, if you are out there, you're going, no, seriously, this is so brain-numbingly boring. Yeah, I get it, don't get me wrong, this is the easy stuff. Chapter 8, it literally goes from 0 to about 1,000 because we suddenly throw in the financial solver as well. Your CAS calculator becomes really important. So here's some examples. A principal value of $10,000 is invested in an account earning compound interest. Now again, that's the trick in the exam, to know what it is you are doing, which formula to use. It's working compounding interest monthly, or compounding interest monthly at a rate of 9% per annum. Now, before I go any further, whenever I do these questions, I'm like, right, I'm already going to work out my value of R. And weirdly, the language in the textbook has changed this time around because they're now calling it a growth multiplier. Interesting. A growth multiplier. Well, that's basically the value of R. So what I tend to do is I say, well, I've got 9% per annum. I've got 12 months. So basically, I'm going to do 9 divided by 12. 9 divided by 12 gives me 0.75. And again, that is percent. That is not my growth multiplier. That's just my value of little r. So what do I now need to do? Well, my capital value of r is my little value of r, 0.75. I divide it by 100, and then I would add 1. The reason being is interest goes up. You add 1 to it. Later on, you're going to take 1 away, or you can do 1 minus this. So again, firing up my calculator, 0.75 divided by 100 plus 1, 1.0075. So there we go. So we've now got R, which is my growth multiplier, as 1.0075. Ka-ching, thank you very much. Let's make myself some space by moving this up a little bit to here. Write down a recurrence relation for the value of the investment after n months. It was a pretty easy question. Look, don't get me wrong. If I'm teaching you, you will know that I'm extracting VCAR questions and I'm showing you that the start of every VCAR question is relatively easy. But believe it or not, for the easy questions, roughly 40% of the state get the easy questions wrong. And VCAR are actually quite tricky in the way that they do these questions, right? So just trill, yeah, you'll get that 40, trust me. People who actually have followed my YouTube channel, what have you, have actually done pretty well. So, not that I'm bigging myself up because that'd be a bit awkward. Write down a recurrence relation for the value of the investment after n months, right? So a recurrence relationship would be V0 is equal to 10,000, comma, V of n plus 1 is equal to 1.0075 times V of n. Now again, my advice to you is when you see VCAR questions and you see that number there, could you now turn that back into an interest rate? Could you turn it back into a monthly interest rate? Could you turn it back into an annual interest rate? Because in maths, what you do forward, you have got to go backwards. Yes, I am indeed from MGS, okay? So yeah, 40%, trust me. When I go through VCAR exams later on, I generally try and talk about the exam percentages, and there are some pretty scary percentages out there, and you'll sort of shake your head and go, but why? because sadly VCAR have made the exams harder and harder and harder, and they trip people up. So hopefully I will actually help. Write down, I'm not reading that comment. Write down a rule for the value of the investment after N months. A rule. It is important for you to be able to go from a recurrence relationship into a rule. Again, a significant proportion of the state can't do it, and they lose so many marks. A rule always starts with Vn. So in this situation, I'm going to do, now I do it slightly different from the textbook. I always do V0 times by my value of R, 1.0075, and again to the power of n. All right, and again, there are videos on mathsguru.com if you actually want to watch where that came from. Right, that was a previous video. I also did it in a previous live stream. Use this rule to find the investment after 4 years. Again, I'm not going to insult your intelligence, but if it's after 4 years, what is that value of n? Now, don't all shout at me to the board. Thank you. Oh my goodness, I need to give up teaching and go and work at Coles. Now, a lot of people will turn there and say, well, after 4 years, that n is 4, isn't it? And again, it is so easy to get tricked here because this formula here is actually month to month to month. So actually, that value of n wouldn't be 4, it would be 48. All right, so there we go. So 48 would be the floating number. Okay, here we go. So what have we got next? Calculating the rate of interest. This is not in any textbook. And when I get to amortization tables later on, this is going to basically rule your name. All right, this is going to rule your life, because if you can find a rate of interest, life becomes easy. If you are following along and a summary book or what have you, put this in there, because the rate of interest is given by how much interest was added divided by the balance or the amount of money that there was there before the interest, and we times by 100 to get it into a percentage. I'll do some example, but I've actually worked for the UK equivalent of Coles, believe it or not, and that was fascinating. Now, the last part of this video, again, is massively important. You can do it on your CAS. The textbook, for some strange reason, does it in a completely different way now. I think it's way confusing, all right? So for this situation, I'm gonna diverge. I've opened a bank account. All right, and I've basically opened, well, let's say I've opened 4 different bank accounts. And what I've done is I've opened one account that is paying annual interest. I've opened one account which is paying me interest quarterly. I'm opening one account that is opening or paying interest monthly, and then one account that is paying me interest daily. And again, bank accounts over here pay interest every single day. All right, that's true of loans and sort of bank accounts. Now, assuming that I open each bank with $6,000. I wish I had $6,000. Actually, I wish I had $6. Whole new discussion, moving on. And each of these banks has an interest rate of 9%. Now, what I can do is I can actually work out that if I opened my bank account with $6,000 and at the end of the year just got interest once, I would get $6,540. How did I work that out? I worked out basically what 9% of $6,000 was, right? So 9% of $6,000. When I do quarterly, I'm getting interest every 3 months. So after the first 3 months, I've got 6,135. But then what happens is I start getting interest on the interest. So now I've got 6,270 after another 3 months. And then I've got more interest on the interest. And ultimately, I'm ending up here with, damn, I'm getting extra $18.50. So by getting that interest quarterly, I'm not getting 6,540, I'm getting 6,500, I'm getting more money. But hold on a moment, it was the same interest rate, isn't it? How do I get more money? Well, because I'm getting interest on the interest. Yeah, that's a lot of dollars, trust me. That's more than I'll ever see in my life. If I get my interest monthly, then I'm getting interest paid 12 times. In this situation, I'm getting even more than I would if it was quarterly. And likewise, if I look at my daily interest, and all of this will be taught in a later video, then basically 6,564. I'm getting more money. But how? It is an interest rate of 9%. Well, what I can do is I can actually work out what we call our effective interest rates. That's these red values at the bottom here. Now, the way I do that is I take how much interest I've got and I divide it by how much I started with. So in this situation here, if I want to work out where I got that 9.31, I know that I started with $6,000. I've got 6,558. So if I do $558 and what is it, 50 cents, I divide that by what I started with, which was my $6,000, and then times it by 100. He says, writing 1,000. Come on, give me the rubber. Let's see what comes up. So 558.50 divided by 6123. Hit enter. Would you times that by 100, please? And whoa, OMG, 9.31%. Thank you very much. So if you are following this and not lost in the conversation about what school you go to and whatever else, then basically you hopefully will now realize that by paying interest quarterly, you are actually getting a higher rate than 9%. You're really getting an interest rate of 9.31%. And likewise, if I do the same calculation here and do 562.84 divided by 6,000, I get an interest rate of 9.38. And again, if it's daily, 9.42. Now, I'm going to ask you a question. Does that mean that a high interest rate or a high effective interest rate is a good thing? Because VCAR will need you to understand when that will be a bad thing. Now, when I pay money in to an account, I want the bank to give me money. I love money. But if I have a loan, I don't want them to be charging me interest every day because basically they're going to get more money from me. So if I want a loan, I actually want to pay interest as less as I possibly can, all right? Do you have a written formula I can down for this? Oh, of course I have a written formula. I'll come back to that in a moment, psychopath. Just bear with me, okay? But I promise you the calculator makes life so much easier. Right, so again, as I've said on this slide here, you basically can just take the interest that was added, as I say here, $558.50, divide it by how much I got before I had got any interest, $6,000, and times that by 100. Right, let's use the CAS. The CAS is your savior here. Like, lo and behold, your CAS is your savior. So I'm going to fire up the TI Inspire. If you have a class pad, just beware that actually your formula is slightly different. For the TI Inspire, you put your nominal rate of interest, your annual rate of interest first, then the number of compounding periods, how often the interest is paid. For your class pad, you actually do it backwards. So if I'm doing this here, I'm going to go menu, finance, finance, interest conversions, and then nominal and effective. So I'm going to hit on effective. So I've got the TI Inspire. Let's go back to that previous example. What was my interest rate for my bank account? Well, it was 9%. If I do comma and I say 12, then what I'm saying is, let's see what happens. This stream makes me feel some sort of way. The stream makes me take legal studies. Oh, that hurts. So basically, there we go, 9.38. If I go back to my previous screen, did I get 9.38 for monthly? I absolutely did. There's my 9.38 for monthly. So your calculator actually gets all this done for you. And the exam uses this over and over again. And as you can see here from this particular screen, what we can see is I've worked out the effective interest rates for yearly, i.e. paid once, for quarterly, paid 4 times, for monthly, every month, and 365 daily. And again, cannot believe the number of people out there who do not know there are 365 days in a year. Come on. Rightio, calculating the nominal interest rate. Well, it seems sensible that if we can do things one way, we can actually do them backwards. And so if you are given an effective interest rate, then basically what can you do? You can actually reverse it. So in that situation, if this was my effective interest rate paid over 12 payments, then effectively we can turn it back. And obviously with some rounding there, we get to 9. Right, who are psychopath? You said, is there a formula I can use? Knock yourself out. Take a photo, take a screenshot. It is there. It is horrendous. No. But anyway, some people like formulas. I get that. Put it in your summary book. I'll leave it on there. I'm not actually going to use it because, to be fair, I prefer to use the calculator. And because General Maths is a calculator-enabled exam, fully calculator, then why would I need to use that? unless they ask for it in a sack. Brooke would like to borrow $20,000 that she will repay entirely after 1 year. She is borrowing money. There is a trick to this question. She is deciding between two loan options. Two loan options, lucky her. The first one is 5.95% per annum, compounding weekly. The next one is 6% per annum, compounding quarterly. Calculate the effective interest for each of those there. All right, let's do that. So, effective interest, not def. Effective interest, what have we got? So for the first one, 5.95, I'm going to do comma, and it's compounding weekly. How many weeks are there in a year? Oh yeah, 52. There we go, comma 52, hit enter, and out comes now to 2 decimal places. I'm going to look at this for 2 decimal places. I've got 6.13%. Let's work out the next one. EFF of 6%, comma, compounding quarterly. There are 4 quarters in a year. Hit enter. Oh, what do I get there? 6.14%. Which investment option is best and why? Ah, well, it's got to be B, hasn't it? It's higher. No. And that goes back to a little bit what I said earlier. It isn't good because this is a loan. You don't want a high interest rate for a loan. You want a loan to have the lowest interest rate you possibly can. So you're looking at 6.13. And in that situation, the trick to the question would have been option A. And believe it or not, guess what? I've seen that question in at least a sack every single school I've ever been in. Just throwing it out there. Marissa has $10,000 to invest. She's going to put money in. She chooses an account that will earn compounding interest at a rate of 4.5% per annum, compounding monthly. Use a CAS. I'm not going to do that now because hopefully you are absolutely able to do that. Now here's the fun stuff. Here is the VCAR questions. Now I always go through VCAR questions, and these are the ones that tripped people up. The nominal interest rate for a loan is 8% per annum. When rounded to 2 decimal places, the effective interest rate for this loan is not. Okay, so let's have a look. EFF, brackets, it's 8, comma, right. If it's daily, 365. Hit enter. So when it's rounded to 2 decimal places, that's 8.33. That's actually right. So in which case, that is not my correct answer. So what is the next one? So EFF, now let's do 8, comma, weekly. 52 weeks in a year, 8.32. That seems to be correct. It's not B. EFF of, what is it, 8, comma, we've got fortnightly. There are 26 fortnights in a year, 8.32. As far as I'm concerned, I would suggest then C would be my correct answer. Now, ideally in an exam, you would then check D and E just to make sure you haven't made a mistake. So I'm just going to do that now. EFF of 8, 12. That's 8.30. That seems correct. And again, EFF of 8, quarterly, which is 4, 8.24. So there we go. I'm fairly sure that actually it is C. Next one, consider the following amortization table. Now I haven't done amortization tables, they're coming in a lesson a little bit later on. And believe it or not, I believe the exam, Fortnite, I actually played Fortnite once. I was going to stream it for a while, but I died. Horrible, horrible deaths. And I didn't quite like it when people danced over me when I died. I thought that was a little bit sick. Whole new discussion, whole new streaming. Let's leave that there. So an amortization table is going to come up really, really important. Being able to read them, find missing values, understand where they came from. But here's the trick of the question. They're actually trying to do things backwards because general maths isn't just about regurgitation, right? You're not some sort of mummy chick throwing up into a baby chick. That's not what we're doing. That was a horrible mental image. The annual interest rate for a loan is 3.6%. Interest is calculated immediately before each payment. For the loan, the repayments are made weekly. So what they're saying is, are these payments weekly, fortnightly, monthly, quarterly, yearly? Right, well basically, how do we do it? Well, I work out my interest rate. And how do I work out my interest rate? I take the rate of interest, so in that situation it was 900, divide it by its previous balance. So that came from 300,000. And I times that by 100. Fire up my calculator. He says, not firing it up. So what do we got? 900 divided by 300, 1, 2, 3, hit enter, and I'm going to multiply that by 100. There we go. So whatever is happening, I am being charged interest. Each of these payments represents 0.3%. Hold on a moment, 0.3%. Well, I know that my annual rate was 3.6. So if I take my annual and divide it by this 0.3, if I do 3.6 divided by 0.3, so if I do that 3.6 divided by 0.3, it gives me 12. 12. What has 12 in a year? Months. So in this situation, the correct answer would have been C. Again, it is better than McDonald's. All right, that's it for this particular lesson. So I'm done. What I'm going to do is I'm just going to open up my next presentation. I'm just going to put this on pause for a second, and I'll be back in about 15 seconds. Okay, I was gone for like 36 seconds. You need a Maths Guru Fortnite stream, please. Yeah, we'll see. Yeah, maybe Crash Bandicoot, yeah. I think that's about my level at the moment, but we'll leave it there. Right, here we go. So, that's chapter 7 done. Believe it or not, that's the foundations for what we're about to do now. I'm going to probably get through 8A and maybe a little bit of 8B before I live stream again next week. So in the next couple of weeks, I will basically finish this and then I will go back and I will do data. And I imagine way more people are going to be doing data. So spread the word out there if you're in a school that are doing data, all right, because that's a pretty big module. So what do we got here? It's a brand new section of the course, and really, to be honest with you, a CAS calculator is going to be vital. If you don't have a CAS calculator, you are stuffed. Now, the group I'm currently teaching are probably sick to death of me talking about this formula here, that recurrence relationship, where we have V0 is the start number. Our next term is equal to R, this multiplier. And again, if I have a value of R here, which we started to see in that previous video or the previous section, times V of N plus or minus D. If you remember, that R basically gives it some sort of growth or decay, and that D gives some sort of payments or not payments, all right? So here we go. Jack Sweeney, I'm well. How are you? Thank you very much for checking in. I'm always well. Right, here we go. So the value of R is 1, we have a linear sequence. When the value of R is between 0 and 1, we have a geometric sequence that will decrease. If it's greater than 1, it will increase. Again, this is just a recap. Now we're actually going to combine them because previously we haven't actually had geometric sequences with things that are added on or subtracted. Now, well, it's no different. It's a formula. We just follow this. Write down the first 5 terms of the sequence. Now again, believe it or not, 54% of the state get these questions wrong. I'm just going to let that sink in for a moment. 54% of the state is going to get this wrong. Why? Basically, because they do not, and I'm going to write this politely, RTFQ. Read the flipping question. Why? It's either they don't read the question or they can't count, because it says here, right, the first 5 terms. The number of people who actually do more than 5 terms is relatively terrifying. Hi, Stefanos, too wavy. All right, really nice to meet you too. Oh dear me, 1, 2, 3, 4, 5. I actually do the boxes, believe it or not. Why? Because I'm 147 years of age and I don't want to lose a really easy mark. How am I going to do this? Well, believe it or not, if you've watched any of my previous videos, you'll know that I quite like the CAS. It makes life easier. Why? Because the first thing I'm going to do is I'm going to put 3 in my calculator and hit enter. Oh, there we go. That's my first term. Then I'm going to let it do all the hard work for me. So I'm now going to do 4 times answer. It's going to take that previous answer and I'm going to minus 1. Oh, hit enter, I get 11. I don't need to do anything else because if I hit enter, I get 43. And if I hit enter again, I get 171. And if I hit enter again, I get 683. Why do I have to do the hard work when the calculator's there doing it for me? I am 147 years of age. I look reasonably good for 147 years of age. And we'll leave those age comments there. Let's not be ageist. Now, compound interest investments with I can't believe how long these titles get. Basically, what we're saying is we're going to get interest, but we're also going to pay money in. Because if you've got a bank account, lucky you, I'd like to have one of those with money in it, but that's a whole new discussion. If you have a bank account, then I'm hoping that bankers are going to give you interest. They're going to give you some form of interest, which is that value of R, but you're probably going to make payments in, I don't know, birthday money, Christmas money, your job money, that under-the-counter money you're getting. Leave it there. So in the previous chapter we were looking at, we know this value of R was given by 1 plus or minus this little value of R here. Right? Now that little value of R was your annual interest rate that was compounded either monthly or whatever else. Right? So we're going to now look at combining the two of them. We've talked about different compounding periods. I'm not going to go on, I wish I looked 20. Yeah, if I turn the lights off and sit in the dark, I'll probably look 20. That's a whole new discussion. Fred has saved $5,000 and invests this in a compound interest account paying 4% per annum, compounding yearly. All right, so first thing first, that's really nice. That means I don't have to change this 4% in any way, shape or form. I do, I have to do the R. He also adds an extra $1,000 per year. All right, so $1,000 each year. Model this investment using a recurrence relation. Well, okay, they've given me the recurrence relation. V0 is my principal. How much do I open my account with? $5,000. Ka-ching. Now you might be sitting there going, why am I still watching this and I've got nothing better to do on a Thursday night? Well, that's the question I'm probably asking as well. Normally I'm talking to way less than this people. I'm normally talking to myself. Anyway, and there I was thinking I was going to go viral. I was thinking Twitch, everyone will dive on this. They'll tell all their mates, they'll be like, maths gurus on. And then I was like, yeah, nah, probably not. Probably a killer of friendships. But anyway, you're probably sitting there thinking this all sounds very similar, all the same, and it is. I promise you, financial maths is so samey. It's ridiculous. But people make mistakes on the nuances that come later on. Right, what is my value of R? Well, my value of R is given by my little value of R divided by 100. In this situation, I'm adding 1 because I'm interest. So that's going to be 4 divided by 100 plus 1. Which is going to be 1.004. And again, I'm just checking that. My head is telling me, are you sure? Don't make a mistake. Plus 1, 1.04. There you go. Damn, making a stupid mistake. That could have cost me huge amounts for this particular exam. But there's my multiplier. And so we get V of n plus 1 is equal to R, which is 1.04, times V of n. Now in this situation, I'm adding $1,000. I'm adding money in each time. So here we go. We're going to have plus 1,000. Ka-ching. Job done. It was that easy. And it's something that's examined in SACs over and over and over again. Nor invests $1,200 and plans to add an extra $50 each month. Oh my God. How typical of maths teachers. We've just changed the numbers and perhaps the name. Now, in this situation, the account is paying interest at 3% per annum, yay, but it's compounding monthly. So the first thing I'm going to do, and I always do, is I say, well, I want 3% divided by 12. I don't want to get the wrong value. So I'm going to do this off screen, 3 divided by 12, and that gives me 0.25. Now again, that's my little value of R in my equation. Again, model this using a recurrence relation, yada, 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 yada. Right, what do we got? So V0 is my principal, which is 1,200, comma. V of n plus 1 is equal to. All right, so I've now got to turn this little value here into my big capital R. So I'm going to take that 0.25, I'm going to divide it by 100, and I'm going to add on 1. Why am I adding on 1? Again, I'm adding on 1 simply because I want to make sure that I'm adding my interest on. That gives me 1.0025. So 1.0025. I'm going to write 1.0025 times by V of m. And because they are making regular additions to the principal, let's move this over. I'm going to therefore add on $50 each month. Ka-ching. Thank you very much. Right. How much money does Devon have to pay if he borrows? I'm going to say, right, stopping reading those. Albert has an investment that has modelled. Now you're going to turn around and say, well, am I teaching anything? No, this was exercise 8A. It is recapping all of chapter 7, making sure that you can take that and just adding that little bit at the end of adding on or taking away a value of D, having a multiplier and a value of D. Notice now we've given you the recurrence relation. You will see that in VCE exams over and over and over again. They will give this to you, but they will then want you to turn this back into an annual interest rate. That's the trick, and that's what actually messes people up in their exams. State the value of the initial investment. That really is for people who struggle with maths. So there, $400. Do you have to write the dollar sign in a VCE exam? Interesting. I would. Please write the dollar sign. Can you write in pencil? I really wouldn't. Whole new discussion as to why. Do not do that. How long have I got? 20 minutes. Determine the value of the investment after Albert has made 3 extra payments. All right, so how are we going to do that? Well, it's a recurrence relationship. I can do this on my calculator. I know my start amount is 400. Put 400, hit enter. How do I now get each one after one after one? Well, I'm going to do 1.005. This basically is just a formula. Where I see the V of n, I can put A and S in my calculator. So there's my 1.005. I'm going to go control and minus to do my answer. Actually, I'm going to go back there and put a times in just in case. Don't want to make a mistake. I'm going to put plus 30. Right, it wants 3 extra payments. So 1, 2, 3. Hold on a moment. Do I write 496.4808? Now, I'm pretty sure anyone who's still watching this is probably screaming at the screen going, no, you idiot, you don't write that, get a grip, you write it to 2 decimal places. All right then, so why is it if I put this in my calculator and that comes out as an answer, everybody in the state writes $19.5? No, we are not a restaurant on Swanston Street or these really high class and swanky restaurants who think that knocking that last zero off is posh. No. That's $19.50, all right? So in this situation, write $19.50. This case, I'm going to round to 2 decimal places because it's money, in which case I would suggest that 496.48. And they told you here how to round it. Now be careful there because VCE exams every now and again change that to the nearest dollar, just to try and trick you. You'll know how to do the maths, you'll trip. What will be the value of his investment after 6 months? Okay, oh well, this is really difficult, not. So if I go back up, I've got to redo this, I'm afraid, because I did something silly in between. So 1.005 times my answer plus 30. Now again, this is after every month. What did I want? After 6 months, 1, 2, 3, 4, 5, and 6. So in that situation, I would write, he says not in highlighter, $594.42. Now, again, thank you very much to the nearest cent. Don't forget the nearest cent. A lot of people out there go, oh, I can't round to decimal places. Here's a helpful piece of advice. 3 or 4 years ago, VCAR would only knock you off 1 mark if you rounded incorrectly across the whole paper. Unfortunately, they then changed the way the papers are marked. Now, they knock off 1 mark every single time you round incorrectly, and there are between 6 and 8 questions every single year that ask you to round. And I have known many people turn around and go, oh, I don't know how to round. Well, okay, I'm sorry about that. Learn, right? You're old enough now. Oh, I feel like I've just told you off. Learn. Plot the points for the value of the investment after 0, 1, 2, and 3 months on a graph. Probably not going to spend too much time doing on that. But ultimately, you have to make sure you have 0, 1, 2, 3 months on your graph and make sure that you do it accurately. I wanted the points plotted, so basically you would do 400 and then your next point and then another point and then another point. And you should get a bit of a curve. But again, I'm not going to spend too much time because I could spend most of my life drawing graphs, okay? This is the same example. I just gave myself another screen in case. Here we go. Massive. Right? I notice I'm down to 6 watchers now. I don't know what I'm doing wrong. How do I make this any more entertaining? How do I make this any more interesting? No, I'm not doing a Fortnite stream in the middle of it. That would be stupid. All right? Not happening. Right, what do? This is the stuff that gets thrown into sacks left, right, and center, and people stuff up. They just don't know how to do it, all right? So, in this situation, I've got a recurrence relationship here, where AN is the value after N months. So the first thing I know, I've got 1.005, that is my monthly value. So my capital R, which if you remember, which is R divided by 100 plus 1, they've given me this value of R. I know it's 1.005 is R divided by 100 plus 1. So what I tend to do now is take 1 off of both sides. That gives me 0.005 is R on 100. And then I times both sides by 100. So R now would be 0.5. Is that my percentage? Well, as it turns out, that is per month. It doesn't want per month, it wants your annual interest rate. Well, because I know there are 12 months in a year, I would multiply that by 12, and in which case that would give me an interest rate of 6%. Now again, I just test it backwards. So let's see, 6 divided by 12, divided by 100, plus 1. Just following that formula for R again, 1.005. I'm right, I can't have made a mistake. What about the next one, 1.012? This one is trying to trick you. Why? Because it's actually a quarterly interest rate. This is my quarterly interest rate. So I have 1.012 is equal to my little value of R on 100 plus 1. Let's take 1 away from both sides. 0.012 is equal to R on 100. Times that by 100, what do I get? I get 1.2%. Is that little value of R, but that's 1.2% per quarter. How many quarters are there in a year? Times by 4, absolutely. Multiply that by 4, and that gives me 4.8%. If you are heading into a SAC and you want to smash your exam, that's what you need to do. And guess what? 8A is done. We are smashing through Chapter 7, Chapter 8. Guess what I'm going to do? I'll be back in a short moment after this commercial break. I've always wanted to say that. I'm a bit of a frustrated TV presenter. Maybe I should do the news. Nah, can't be that serious. All right, so this is going to be the last part. I've got about 13 minutes left. Thanks very much for those of you who have stuck by and watched this so far. I genuinely hope it's useful, all right? I'm serious. I know that you guys, and I imagine if I'd have done this 3 years ago before home learning, probably a lot more people would have watched it because it would have been unique. I'm pretty sure that most people now, you say you've got to sit and watch some bald guy talking about maths, you're probably going to turn off and say, I'd rather shoot myself in the kneecaps twice. Okay, I'm sorry. By the way, did you see the merch? I have merch. Look, Maths Guru merch. Whole new discussion. Go to mathsguru.com, click on merchandise. Mugs. Hoodies. I know. Anyway, whole new discussion. Recap. Let's go to a recap. What's a recap? No, I can't do it again. It's the same formula. It's exactly, are you trying to tell me that Chapter 8 is using the same formula as Chapter 7? Go figure. Now, the great thing is, I do it slightly differently. Cambridge does it little bit by little bit by little bit by little bit. I don't. Let's learn the whole formula, work out what it does, and then sort of break it down by what we need to. All right. Reducing balance loans. Now, when we actually take out a loan, and the strange thing here is that you guys probably have never taken out a loan, and yet we are asking people, left, right, and center in general maths, to understand loans. All right. When you take out a loan, and this is sort of a crash course in loans, I have currently got a loan of about $350,000 for the place I live in, all right? Now, that's actually not a lot in comparison to what a lot of people have. That's taken out over 30 years. Now, I am paying off that loan at about $2,000 per month. All right, so whatever I earn in teaching pretty much goes into that, yeah? The rest of the money, I have no idea, I'm broke, but that's only just, anyway, so I'm paying off 2,000 years. Now you might turn around and say, well, hold on, all you need to do is divide 350 by that $2,000 and that's how long we're going to be paying the loan off. No, because the bank charged me interest. Now actually, over those 30 years, what happens is they look at the 350,000, they add on interest first, and then they knock off the $2,000 that I've paid. So they add on the interest, knock off the $2,000. Add on the interest, knock off the $2,000. At the end of 30 years, I have borrowed $350,000 from the bank. I will have paid back nearly $800,000. Now let that just sink in for a moment. I am going to be paying back more than double in interest what I borrowed from the bank. And that's why interest rates and mortgages are so important. But the point of it is, you borrow some money, you add on interest, and then you take away a payment. Now that's called a reducing balance loan. The reason it's called a reducing balance loan is because we want the balance to reduce. That's the whole point. Now, the shame of it is some people take out mortgages where the interest is actually more than their payment. And that's where basically things spiral out of control, people lose homes and all sorts of stuff. So it's a good idea to understand the general idea of money. A reducing, no, that's the same formula. I haven't made a mistake. It's exactly the same formula, believe it or not. I'm not kidding. The point of it is, a reducing balance loan works in exactly the same way. The only difference is that my minus D there. Now again, think about what I've just been saying. I open my account with the money, I am charged a rate of interest, and I pay some money off. Now generally speaking, I'm going to pay that off monthly. Have a look at an example. Hopefully it will make sense if we scaffold it and build it up, but it's all building off of the chapter 7 stuff. Flora borrows $8,000 at an interest rate of 13% per annum, compounding annually. Now again, compounding annually, lovely. I don't need to have to do anything with that 13%. I can use it as it is. She's making yearly payments of $2,100. Again, the fact that it is a yearly payment and it is compounding annually or yearly makes life a lot easier. Construct a recurrence relation to model this loan in the form V0 equals. Right, well V0 equals $8,000. I am going to equals try that one again, comma, V of n plus 1 equals, what is my value of R? 13 divided by 100 plus 1, so 1.13. Again, just checking that. Don't want my brain to do a bit of a brain burp, and I deliberately said burp there, 1.13. So 1.13 times V of n. Now she's making a payment. She's taking money off the loan, so she's taking off $2,100. Ka-ching. There we go. That's my recurrence relation. And if you can build this, they will come. That's probably a pop reference from you guys that will have absolutely no idea unless you're about 64 years of age. Anyway, Field of Dreams. Yeah, I know you still got no idea. That's as easy as it gets. Construct, oh no, it's the same. Oh no, how have we made it different? We're now compounding monthly. She makes monthly payments of $250. Construct a recurrence relation to model the loan in that form. Again, it's exactly the same. And I'm so sorry that I keep repeating that, but I think what I'm trying to say is, if you get the basics, the rest of it is just the same. Right, let me go. What I've got, 15% per annum, but it's compounding monthly. So I'm going to have to say that my value of R is 15 divided by 12. Let's not put that there. Let's make that my little r. That sounds minorly rude, but anyway. 15 divided by 12. Put equals 1.25. But I want my big value of R. So that is going to be 1.25 divided by 100 plus 1. I'm going to do that off camera if that's okay. Divided by 100 plus 1 gives me 1.0125 times V of n. Am I adding money on or taking money away? Well, she's making a payment of 250, so it's minus 250. Now, a word of warning there. Last year, a lot of my maths group got really confused there. They went, well, no, but I'm making a payment, I'm adding it on. Not with a loan, you're not. With a loan, you're actually paying money off. You're reducing the balance. So by paying that $250 in, you're making your loan smaller. So that's why it's minus 250. And when we get to the CAS on our next session, then basically everything is the opposite way than you're expecting it to be. So that is my recurrence relationship. Basically, Alyssa's loan can be modeled by the following recurrence relationship. All right, so they've obviously updated the question here. Use your calculator to find the balance of the loan after 4 payments. I'm not going to insult your intelligence, but again, what do? I basically use my calculator. Put in this V0 of 1000. Put this in as a formula. Do 1.0125 times answer minus. I've literally just copied this in. Where I've seen the V of n, I've put the ANS. It wanted it after 4 payments. I've done it 1, 2, 3, and 4 times. So now the question is, how much does she owe after that period. What on earth is that? Well, basically, when we round that to 2 decimal places, it means that she's actually going to owe 4 cents. Now, we're going to round that down there. The bank won't be very happy about that, but it's going to be 4 cents. Find the balance of the loan after 2 payments have been made. Well, again, after 2 payments, that gives me that value there. What I'm going to do is I'm going to stop on annuities, believe it or not, and I'm going to say, for those of you who are still with me, thank you very much for watching. Does anyone have any questions that are remotely PC and anything to do with the mathematics? If you have, put them in the chat now. If not, I'm going to call it a day. It's almost 9 o'clock. I try not to make these any longer than an hour. This video will be uploaded to YouTube for you to watch again if you want to, and I should be back this time next week at about 8 o'clock, if that helps. If you think it's going to be better earlier, let me know. Does anyone have any questions? Thanks, Mass Guru, for the streams. You are more than welcome, Psychopath. Don't worry about it now. Now, with the data stuff, I'm going to stick with, I will come back to the data question. But if you want to, Psychopath, send me an email. All right, if you need to, send me an email. I will more than happily come back to you with answers if I can. That's what I'm here for, yeah? And as I say, the financial streams will be here for you later on. Maths Guru, I've got all the data, I think, on my videos there. So I'll pretty much be just going through those again if you want to sort of get ahead of the curve. Anyone else got any more questions? Psychopath, if you can actually also spread the word for people you know. I know it's not particularly cool, but if you can let people know that the stream is here, that would be great. Stefanos Tuavi, have I lost you? Are you still there? Thank you very much for making so many comments. Believe it or not, you've earned me an award, believe it or not, for having well and truly over 100 messages on this stream. I'll read them all a little bit later on. Okay, I'm going to call it a day. Thank you so much for watching. I look forward to seeing you and maybe a few more people next week. You take care, and I'll see you again soon. Bye-bye. Now I've got to wait 30 seconds for it to catch up. It's a bit weird, really.